Today we're doing 2.3. This time we're doing our second type of transformation, and that's a rotation. So rotations, we have a few definitions here. The first is center of rotation. And a center of rotation, most of you guys can probably figure out what a center of rotation is. It's the point where we rotate things around. So for example, I have this figure here, right? And as I rotate, where does it rotate around? Well, it's in this case, it's rotating around the middle, right? But I may have something else, like some of my tools do this. Here's my ruler tool. So this one, when I go to rotate it, it's not going to rotate around the middle. Where is this rotating around? We can see here that it rotates around this specific point as I rotate it around, right? Not around the middle. So there may be different centers for rotation, and then angle of rotation just refers to how many degrees it rotates. So you're going to need to be able to draw this. Well, you can practice more in class if you want, but for right now, I'm just going to go through the steps here. If we want to rotate something, basically we have our figure here DEF, and we'll treat this as just 3 points, and we're going to rotate those 3 points. In this case, it says 75 degrees. Yeah, and we'll do a clockwise rotation. So in this instance, the first thing we need to do is draw a ray through one of these points. I have this here, so I'm just going to mark the points. Okay, so they're nice and obvious. And then I'm going to go ahead and get this, and I'm going to draw a ray. I should probably put that point of rotation there. So it's easier for me to do this. Okay, and then I can draw my ray. Stop it. Close enough. So here's my ray. And then I can go ahead and find what 75 degrees is. So in this case, I can put it here. I can, oh, it's pretty close already. If I'm going to do a clockwise rotation, remember clockwise is in this direction. So I need to line it up so 75 degrees is even with the ray there, and then I know that I just need to mark a point at the end of that. So I can go ahead and use another mark. I'll use blue for that. So I can mark that at 0. And then I can use this guy again. And that can mark so that's a 75 degree angle ray, right? This is a ray, it goes on forever. So I took my ray from Q to E here, and then I made it another ray that is 75 degrees clockwise from that. And then the final step for that point is to just measure the distance. So for this case, since I have a metric ruler here, I'm going to say that's what's that, 5.5. So I'm going to say, ooh, 5.5 centimeters, and I'm going to go 5.5 centimeters down here, and measure out 5.5. That brings me to this point right there. So I know that this point, that black point there, I'll go ahead and label it. Here's my black point. I know that this is the same distance from Q as E, and it's been rotated 75 degrees clockwise. Therefore, I'm just going to label this one as E prime, right? I can do the same thing for the other two, and feel free to fast forward and skip this part because I'm just going to do the exact same thing. Let's see, we'll do a red one here. And then just move it a bit. And still red. And I can find 75 degrees. Put that there. 75 for that one. Gives me a point there. And 75 for that one. Gives me a point there. Oops. Okay. And then I'm doing this. Hopefully you can do this on your own, but we're repeating the same process with these other 2 points. I'm going to make a ray. Sorry, it's down at the bottom. I'm going to scoot this down so you can see a little better. Too low. Let's shrink this in. So actually, that's pretty good. All right. We're going to do 75 degrees. Oops, I was using blue. Joink. And joink. Okay, and then we just have to measure the distance. And again, in this case, see along here to D it's 3.5, and along to F it's 8.5. So 3.5 is there, 8.5 is there. This is point D prime. And this one out here is point F prime. Cool. So that allows us to make triangle. And DEF. Okay, you saw all the steps involved there, but again, just to reiterate, we make rays to each point in the original figure, and then we measure out the number of degrees that we want. We find that same distance that the original points are, the pre-image points are from our point of rotation, and then we measure out that distance to find each point. Cool. Go ahead and see if you can do these ones real quick. So pause here. Oh, okay. Should look something like that on your own once you've done it. Okay, once we're in the coordinate plane, we don't have to draw them using a protractor and stuff. We can use math, right? You can use some addition and algebra. So in this case, we're only going to do basically 3 different rotations. The first is a 90-degree rotation counterclockwise. Second is a 180-degree rotation. Third is a 270-degree rotation counterclockwise. And then the final one is a 360-degree rotation. Well, 360 degrees is the same thing as before, right? So I take my thing, I rotate it 360 degrees, and voila, it's the same as it was before. So that one's kind of a no-brainer, I think, and we'll just skip it and move on. Right, nothing changes here. For a 90-degree rotation, 180-degree rotation, and 270-degree rotation, we just follow these rules. You may notice that for a 180-degree rotation, it's the same as a double flip, right? If we reflect it across the y-axis and reflect it across the x-axis, it's the same thing as rotating 180 degrees. Also note, unless otherwise specified, we can assume that a rotation is counterclockwise. I know it's kind of weird, but just that's the standard. We're just going to assume that it's always going to be in a counterclockwise direction unless otherwise specified. Note that what about clockwise directions? What are the rules for clockwise directions? Well, you're going to have to figure those ones out on your own. Essentially, though, the hint here is that a 90-degree rotation counterclockwise, right, would be like turning left 90 degrees. If you went 270 degrees, it'd be like turning left, turn left, 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 those 90-degree turns, right? You end up facing the same as if you had turned right once. So a 90-degree rotation clockwise ends up in the same point as a 270-degree rotation counterclockwise. So that's their formula here. Okay, we'll see it applied here. So we're going to rotate this image right here. So we have triangle KLM. We're going to rotate it 180 degrees. Which way? It doesn't really matter. Counterclockwise is the default. So in this case, we can go back to our rules. Sorry. 180 degree rotation means that we're going to make the x's and y's negative. So we're going to make the x's negative, the y's negative. Here are our points. So 2, -1 becomes -2, 1. Similarly, 4, -1 and 1, -4 just become the negative versions of those. We can go ahead and graph this and we can see if it turns out okay. So we go to -2, 1, boop, -4, 1, boop, and then -1, 4, -1, 4, boop, and then I can label these. So this was K, so that's K prime. This means L prime is this one, and M prime is that one. Yep. So does that look like it's pretty good? Does it have the same size, same shape? Yes, it does have the same size and same shape. So we're good on that. What quadrant is that in? Well, we went from, what quadrant is this? Well, they're 1, 2, 3, 4, and then it rotated into quadrant 2. So just a reminder about the quadrants. Okay. Suppose you rotate quadrilateral ABCD in part A by 810 degrees. In what quadrant will that lie? Well, each time you rotate it 360, it ends up back where it is, right? So we can subtract off a couple 360s. So that leaves us with, what, 720 minus 810 for final rotation of 90 degrees. So 90 degrees, basically we can spin around this a bunch of times. It just matters like how many outside of the 360 degree rotations you do. And a 90 degree rotation counterclockwise puts us right here in this quadrant, which is quadrant 3. Wait, why did they say quadrant 2? How did I mess this up? 90 degrees, so quadrant 2, what? Oh, part A, yeah, wrong one, sorry. Yeah, my point stands. I was looking at the wrong figure. Okay, see if you can do these ones real quick. Pause. Hopefully they turned out something like these. Okay, the final little step here though, it would be to basically do our first thing where we're working outside of our coordinates, but we're going to work backwards. So in this case, we just need to find the angle of rotation. Let me grab my tools. I need this thing, and I need this thing, and it doesn't need to be that big, but that's okay. In this case, we have a figure that's been rotated around a point P, and we simply are asking, what is how many degrees has it been rotated, right? This one's actually really quite easy. We find a single point, we make array, and then we find the corresponding point. So in this case, it's B prime. We can make array if need be, and we'll go ahead and do that. So here's B prime, and I'll make a corresponding array, or the same array to the corresponding point. Note, you don't want to do this between like B and D prime. You want to do it between B and B prime. And then we now have an angle that shows the angle of rotation, and we simply measure that angle. Remember, don't measure angles like this. It's much easier to line up one of those rays with the 0 degree, and then we just count up for values. So, 10, 20, 30, 40, 50, 60, 70, 80 degrees. Again, the other common mistake is to count this one and count it as 100 degrees, but it's 80 degrees. We know it's that because it's less than 90. Cool. So they say, oh, it's 80 degrees. Yay, we did it. Good job. Read the steps there. Oh, we can do this one too. Sure. Go ahead and do that one. Pause. Look at that. It was clockwise. 135 degrees. Okay, and go ahead and answer these ones. See what you come up with. So no for the first, yes for the second. Yep, that's all I have. Go do fun teenager things.